Hello everyone, my name is Deniz and this is my Physics 102 lab project video applying Kirchhoff rules on a non-reducible circuit. So let's start by talking about the Kirchhoff rules. First one is the junction rule, and junction rule simply says that the total current entering a junction must be equal to the total current exiting a junction. In this example, this is a junction, as you can see, and we say that I1 plus I2 must be equal to I3. And this is the loop rule. Loop rule states that all the potential differences on a closed loop summed up must be equal to 0. And in this example, if we follow the loop A, B, C, D, A, we get this equation. And the sum of the potential differences created by these elements must be equal to 0. So this is the circuit I used. As you can see, this is a non-reducible circuit, which means we cannot reduce this circuit to a more basic one with using parallel or series configurations. And this is the diagram. These are the resistor values I used, and the power supply was set to be 25 volts. Alright, let's do some theoretical calculations. Looking at point X, we can say that I total must be equal to I1 plus I2 using the junction rule. And we can use the junction rule for point Y, point B, and point E too. So we get these two lines of equations here. Then using a loop rule for O, P, A, B, C, O, we get this third line. And using the loop O, P, D, E, F, O, we get the fourth line. By using these equations, we can get a simple equation like this. And another loop we can use loop rule on is A, B, E, D, A. And this is the equation. So by merging this information with this equation, we can get another simple equation like this. And by using this simple equation above here, we can get the value for I5. And when we get I5, we can get all the other ones. And I'm not going to do them here.
First part, I have set the voltage to 25 volts and measured the I total, and this is the I total. For the first part, and I am calculating the I4 value. Voltage is again 25 volts, and this is the current value we get. Second part, I will be calculating the voltage difference between point A and point B. And as you can see, it is 15.73 volts.
So these are more of the measurements I did. And the first one was for the potential difference between point E and point F, and the second one was for the value I2. So here are the results for the first part, application of junction rule. And here is the potential differences table. I will be using these experimental data to apply loop rule. And this is the result for part B, applying the loop rule. As you can see, these are all closed loops, so theoretical values are all 0. And these are the experimental values I got. So the experimental data mostly matched with the theoretical data. I am happy with that. And it can be observed that smaller measurements caused a bigger error margin. That is because smaller measurements challenge more the accuracy of the multimeter. And the table 3 shows us that the bigger the loop is, the bigger the error margin is, because all these small error margins add up on a loop rule application. And there weren't any significant difficulties with the experiment. I believe that was because the experiment did not need much human work. So that was my lab project. Thank you for watching and see you in future projects.